So this is Dr. Kavita Singh, Associate Professor in Department of Civil Engineering in Institute of Aeronautical Engineering. So today we'll be discussing the questions or question bank or the long answer type questions on remote sensing. So if you remember in the previous lectures, we have just completed our syllabus. We have studied about remote sensing, we have studied about GIS, we have studied about photogrammetry. So today in this lecture, we'll be discussing about the long answer type questions which can come in the exam for long answer type questions. How to solve the questions that we'll be discussing now. So let us start with the questions. What type of questions we can just get in the exams and how to solve that type of questions here. So for example here, explore various sensors used in remote sensing including satellites and explain how they contribute the data. So explore various sensors used in the remote sensing including the satellites, explain how they contribute in the data. So what are the different methods you can just see here? So exploring the various sensors various sensors used in the remote sensing. Remote sensors collect data by detecting the energy that is reflected by the earth, and these sensors can be on satellites or mounted on the aircraft, and remote sensors can be either passive or active. So passive sensors respond to the external stimuli and they record the natural energy that is reflected or emitted from the earth's surface. Various components of sensor systems operating in the visible, infrared, thermal and microwave regions of the electromagnetic spectrum sensors. So all the imaging sensor systems are classified based on the technical components of the system and capability of the detection by which the energy is reflected by the terrain and the features is recorded. So this is how, first of all, we have to see various sensors used in the remote sensing. So what are the different sensors? We will just know. We have two types of sensors here: active sensor and the passive sensor. So active sensor is all weather capability. It will show you all weather conditions. It will be helpful in the all weather conditions, whereas passive sensors is totally dependent on the sunlight. So wherever the sunlight is available, that type of sensors will be working. Now, passive sensors respond to external stimuli. They record the natural energy that is reflected or emitted from the Earth's surface. Various components of sensor systems operating in the visible, infrared, thermal, and microwave regions of electromagnetic spectrum sensors. All the imaging sensor systems are classified based on the technical components of the system and capability of detection by which the energy is reflected by the terrain and features is recorded. Now the classification scheme. So what are the classification scheme here? We have multispectral imaging sensor system, thermal remote sensing system and microwave radar sensing system. So here we can just use this classifications of various sensors, like we have here sensor systems, multispectral sensing systems, thermal sensing systems, microwave and radar systems. Here we have photographic and scanning system. So under this we have multispectral imaging sensor systems. So in this, in case of multiband or photographic system, different parts of spectrum are sensed with different film filters combinations. Multiband digital camera images and videos images are also typically exposed onto the camera sensor through the different filters. Now, electro-optical sensors such as the thematic mapper of the Landsat are typically sensed in the last several bands of the electromagnetic spectrum will be useful in this multispectral images, and typically it is helpful in the digital camera images and the video images which are also exposed to the digital camera and through the different filters. Now, two types of multispectral imaging sensor systems we have here. So one is photographic system, another one is multispectral scanner. So what is photographic system? Suffers from the one major defect and it is considerable to distortion at the edges, and this is due to the large lens opening. And multispectral scanner, it operates on the same principle of the sensing and in the multiple spectral band, but such instruments can sense in a many more bands and over the greater range of electromagnetic spectrum will be happening here. Now, multispectral images are acquired by means of two basic processes across the track and along the track. So there are two types of sensors here. One is across the track, one is along the track. So what is across the track here and along the track here? So multispectral scanning system built up to two-dimensional images of terrain for swath and beneath the platform. And the second type of multispectral scanning system is along the track. So this scanning sensors we can use along the track and across the track. Now, thermal sensing systems. The thermal scanner is one of the most important thermal sensing system, a particular kind of across the track multispectral scanners which senses in the thermal portion of the electromagnetic spectrum by means of inbuilt detectors. So it's a thermal kind of systems which will just only work in the thermal, system wherever in electromagnetic spectrum. If you see thermal region, that region only this works, and it has a inbuilt sensors which works on the thermal region itself. So these systems are restricted to the operating in either 3 to 5 nanometer or 8 to 14 nanometer range of the wavelength. So microwave imaging system. So the fundamental principle of microwave sensing and the conceptual design for radar. So it is stated that the microwave region of the electromagnetic spectrum includes the radiation with the wavelength longer than 1 mm imaging. So various satellites used in the remote sensing. What are the various satellites we use in the remote sensing are? Since the launching of high resolution ICNO satellite series, number of high resolution and satellite have been launched. The important among them are Flickr, Cartosat, Risosat. So these are the three satellites and sensors which are used in the. These are the new trend which are used in the sensor system. Now, in this QuickBird is the imagery. It's a very high resolution image. QuickBird has launched on 18th of October 2001, and this is currently the highest resolution commercial satellite data available through QuickBird. Across 61 centimeter to that means 61 centimeters on the ground. So whatever object 61 centimeter on the ground, it is visible in the image. So that kind of sensor will just acquire the images in the very high resolution, and it acquires the images in the black and white of 2.44 meters and 8 foot multispectral images. So it has a capability of acquiring the images in multiband and as well as in the panchromatic band. So at 61 centimeter resolution, buildings, road, bridges and other detailed infrastructure became visual. 61 centimeter is such a resolution that in that the buildings is easily visible, the roads are easily visible, bridges are easily visible, and easily we can just detail infrastructure we can see in the image. Now Cartosat 1. Cartosat 1 is the Indian satellite sensor was successfully launched by the 9th by the ISRO Polar Satellite Vehicle, and the Cartosat will has launched in vehicle, and it is zero popular and carries two panchromatic camera. So it carries two panchromatic camera. One is to take black and white, and one stereoscopic pictures of the visible region of the electromagnetic spectrum. So what is a panchromatic cameras? Panchromatic cameras which will just click the photos into black and white. Okay, so black and white photos are visible in this image, and the imageries have a spatial resolution of 2.5 meters and cover a swath of 30 kilometers. So imagery will have a spatial resolution of 2.5 meters, will cover the swath of 30 kilometers. So what is a swath here? So this is the swath, it covers of 30 kilometers area. Okay, so it has this capability in the Cartosat. Now Resource Set 1 is the conceptualized and designed to provide the continuity of operational remote sensing with its superior capabilities. So it has a superior capabilities, it has operational remote sensing with the superior capabilities. Its objectives is to provide the continued remote sensing data and integrated land and water management and agriculture, and it is related to the applications of the resources, whatever is available, that kind of resources will be available. Now, satellite carries sensors, sometimes many of them that read varying amounts of energy and reflected from the Earth. So, for instance, a weather satellite, special instrument for recording the multispectral data, and the satellite sensor observes a small portion of the Earth called as pixels. So, whatever satellite will observe, it will call as a pixel. So, how satellite and sensor contribute to the data acquisition, that we have to see. So, electromagnetic spectrum is like having a wavelength of starting from range from 0.4 to 0.7. Just let us discuss about the electromagnetic spectrum. So, electromagnetic spectrum is like from the different bands we can just go through. Like the bands will be starting the range from 0.4 to 7. So, suppose this is the electromagnetic spectrum. So, here we have 0.4. We have 0.7. Okay, so this range is visible range. Okay, visible region. This range is visible region, and from here to here we have the IR region. So infrared region. Then we have again here we have the thermal IR. Okay, thermal IR region. Right. Then we have microwave region. Then we have radio region. So it starts from the 0.4 to ranges to 0.7. So in the visible region, where we see is the region where the light are like visible light, the spectral wavelengths. So visible light is the electromagnetic radiations. So with a wavelength between the 0.4 to nanometer, micrometer we say, to 0.7 micrometers, and the eye is not uniformly sensitive to light within this range and has its peak sensitivity at 0.55 nanometers. So this speaks in the response and functions of the human eye. An eye corresponds closely to the peak in the sun's radiations, emittance and distribution. Now, wavelength longer than the visible red and the subdivided into infrared region, microwave region and radio frequency wavelengths. So the infrared wavelengths we can see here, this is 0.7 to 1 nanometers and is not a uniform region. It's not a uniform region. So short wavelength or near infrared between 0.7 to 0.9 nanometers behaves like a visible light and can be detected by the special photographic film. So this regions 0.7 to 0.9, it behaves like a visible. So this behaves like a visible and the detected photographic film is detected here. So in this we can also call as atmospheric windows. So in the atmospheric windows, where you can see here is in this windows we can just find out the regions like for the passive remote sensing, because from here itself it will allow the light to pass through and it is easily we can detect the photos from this region. So light can be detected by the special photographic film and the region by the spectrum and composed of electromagnetic radiation with a wavelength between 1 mm and 300 centimeters. And it is called as microwave band, and the radiation at these wavelengths beyond the microwave band is valuable region for the remote sensing purpose. Now here we have the microwave bands and thus the valuable region for the remote sensing. Beyond the microwave region, it is a ratio band of very long wavelength and used to the certain applications. So following are the different spectral bands here. Now applications of electromagnetic spectrum. So what are the electromagnetic spectrum's applications here? So it is used in our day-to-day life. So how we can use it in the day-to-day life means electromagnetic spectrum is used like all the radiations, all the waves are used in the day-to-day life. Like the radio waves basically captures the waves that are transmitted by the radio stations, and microwave, this type of radiation is found in the microwave, helps in the cooking, and infrared used in the X-ray machines that we can use in the application part of the electromagnetic spectrum. So this is about the electromagnetic spectrum, which you can just find out the different applications of this waves, and just you can get to know about the different types of application part. So radio waves basically captures the waves and transmitted by the radio station. So in our day-to-day life, we use like in X-rays, we use in the scanning, we use in the capturing the information, we use in the shopping malls. These all radio waves, we use it in the different application space. So in our day-to-day life, we are also using at our home, we are using in the office, we are using the electromagnetic radiations in all the places. In the hospitals, we are using like X-ray machines, we are using for the cooking purpose and helps in the used in the infrared radiation used in the X-ray machines also. So this is about the different you can say about the electromagnetic spectrum, which is relevance to remote sensing, highlighting the different spectral bands and their applications. So their applications is very wide, like widely we can just use in the different fields, and you can just use these applications in the various forms for finding out the information and to use in the different regions to get the more information about it. So electromagnetic radiation is very much helpful in day-to-day life for the all purpose. Okay. So basically here we have the range what I told you about the visible range. So this will work for the passive and the active remote sensing, as I told you before also. Passive and active means, suppose let us take this range here 0.4 to 0.7. Now here we have this region is the passive region, we can say. This region is the passive region. And after 0.7 or we have this 0.9, we have this 1, 2, 3, 4, 5, 6, 7, 8. So like this we have this region is the passive and it is also known as the visible one. Then we have this region is totally active region. Okay, active region. So in the active region we have active sensors, and in the passive region we have passive sensors. Okay, we have passive sensors. So this passive sensors will be helpful in the capturing the information of the area of this ground surface by at the time of whenever this sunlight is available. Okay, sunlight is available. So whenever the sunlight is available, this passive sensor will be there, and this region it is having all weather capability. So all weather capability. So whenever it is a rainy condition, whenever it is a cloudy conditions, in that type of conditions also this satellite sensors will be working every time, and it has a capability of capturing the information in all the weather's conditions. So this is how we can use this applications, and it has a like this sensors like active sensors are used in our day-to-day applications, because as we are using our mobile phones, we are using the scanners, we are using the sensors for opening the door, closing the door in the lifts, and that all we are using as a sensor. So these are all active sensors which are working in the all weather conditions, whereas passive sensors, this is totally dependent on the sunlight. So whenever the sunlight is available, then only this kind of sensors will be working. So about this applications, you can just remember in daily life we use it. Radio waves basically captures the waves and it transmits to the radio station. Microwave, this is the type of radiations which is found in the microwave, and it helps in the cooking and all. X-rays we use in the X-ray machines. So this is what about the remote sensing part. So to find out the more information about this, you can just go through this links to find out the more content, or you can just go through this MNG Ready book to get the information about remote sensing and GIS. So that's all for today. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.